Hi guys, welcome back to my channel. So how do you solve this integral? I am going to solve this integral using the King's property, right? Which says that the integral from a to b of f of x dx is the same as the integral from a to b of f of a plus b minus x dx. So here our a here is really the lower limit negative pi and b is positive pi. So a plus b is really equal to 0. So that will be 0 minus x, and that is going to be minus x, right? So a plus b minus x here is going to be 0 minus x, which is negative x. So our original integral is I, but the integral that I'm going to transform using the King's property is going to be just plugging in negative x wherever you see x in our integrand. So negative x squared divided by 1 plus sine of negative x plus the square root of 1 plus sine. So sine negative x squared is sine square x is the same thing. So this is going to be dx. Now I is going to be the integral from negative pi to positive pi of x squared all over 1 minus sine of sine is an inverse is an odd function, so that is going to be negative sine of x. So 1 minus sine of x plus the square root of 1 plus sine square x, then dx. So this one is going to be, we are now going to sum our integral. That is the original integral I plus the I transformed by the King's property. So the original integral is the integral from negative pi to positive pi of x squared divided by 1 plus sine of x plus the square root of 1 plus sine square x dx, plus the integral transformed by the King's property negative pi to pi of x squared divided by 1 minus sine of x plus the square root of 1 plus sine square x dx. So we can now put this integral into one integral. So negative pi to positive pi of x squared all over 1 plus sine of x. So I'm going to write this one as 1 plus the square root of 1 plus sine of x, sine square x, plus sine of x. Why not? No, plus x squared all over 1 plus the square root of 1 plus sine square x minus sine of x, all this one dx. So the two integrals have been put into one integral. So 2I from the left hand side is equals to the integral from negative pi to positive pi of this one. So I am now going to, so instead of writing the integral, I am going to simplify the integrand, and then I'll come back later and integrate. So I am going to simplify this one out without the integral, and then I will come back for the integral. So we can do this in a different color. So x squared, we are going to simplify x squared all over 1 plus the square root of 1 plus sine square x plus sine of x plus x squared all over 1 plus the square root of 1 plus sine square x minus sine of x. So here the LCM is really this one times this one, but we can now multiply, which is x squared multiplied by this term here, which is 1 plus the square root of 1 plus sine square x minus sine of x, plus x squared multiplied by this term, which is 1 plus the square root of 1 plus sine square x plus sine of x, all divided by this one is like difference of two squares, right? So that is 1 plus the square root of 1 plus sine square x squared minus sine squared of x. So those are the difference of two squares. That's the denominator. Okay, so this one is going to be, you can now multiply, distribute our x squared plus x squared, the square root of 1 plus sine square x minus x squared times sine of x plus x squared times the square root of 1 plus sine square x plus x squared sine of x. divided by the denominator, 1 plus sine square x squared minus sine square x. Okay, cool. Now some things will cancel out. I guess this one will cancel out with this one, and in the end we have x squared plus x squared, which is 2x squared, and this plus this is 2 of that, so we can factorize 2 out, and that will be x squared plus x squared times 1 plus sine square x in a square root, right, divided by difference of two squares. This one I can expand this one. This one is 1 plus 2 times this 1 plus the sine square of x plus 1 plus sine square of x minus sine square of x, like this. Cool. So 2x squared plus x squared is square root of 1 plus sine square x all over. This one will cancel out with this one, and you have 1 plus 1 here, which is 2, which you can factorize out, and that will be left with 1 plus the square root of 1 plus sine square x. Here should have factorized 2x squared out. I'm bad, forgive me for that. So this is 2x squared, 1 plus the square root of 1 plus sine square x all over 2 multiplied by 1 plus the square root of 1 plus sine squared of x. So this one and this one are the same. They'll cancel. 2 cancels 2, and you are just left with x squared, right? So that means that this one here simplifies to x squared, right? So we can now finish off our integral. So our integral is 2I is equals to the integral from negative pi to pi of this thing, which is now has been reduced to x squared. So 2I is equals to the integral from negative pi to positive pi of x squared dx. This one from here is now x squared, which we got. So this is now really trivial. So that is, integrating is going to be 1/3 x to the third power, and integrating from negative pi to positive pi. This is an even function, so it can be 0. So 2I is going to be 1/3, and then pi to the third minus negative pi to the third. So that is going to be 1/3 pi to the third plus pi to the third, because this one is negative pi to the third, so that will cancel up with the negative. That's going to give you plus. So 2I really is going to be 1/3 of 2 pi to the third, and that is 2/3 pi to the third. So 2I is equals to that. We can divide by 2. So 2I divided by 2 is going to be divided by 2. And this cancels, and then your I is going to be 1/3 pi to the third. So that is the value of our integral. Therefore, if you integrate, that is the integral from negative pi to positive pi of x squared divided by 1 plus sine of x plus the square root of 1 plus sine square x dx. This one evaluates nicely to pi cubed over 3. So this one, ladies and gentlemen, is the value of our beautiful integral. So if you really find this video helpful, please give me a thumbs up, subscribe to my channel for more engaging tutorial on integral calculus. I thank you so much for watching this video, and I will catch you up in the next one. Bye bye.